All right, the video today is to teach you how to read this chart. Remember, the file right before this video actually has the notes, the lecture notes that I'm about to go through. And somewhere in the module, it also told you to print a clear copy, which means depending on your printer, you may have had to print it normal as opposed to draft, but you got to be able to read these numbers, okay? But before we get into that, um, we've had some experience with this. When we did the empirical rule, remember the unimodal and symmetric distribution. All of also those synonyms that we learned, the synonym bubbles for the empirical, that is back. The how to ask questions going forwards and backwards, that is back. But the empirical, since it was based on just from experience, we were really limited. Remember how we could just do 1, 2, or 3 standard deviations away from the mean? Well, the normal distribution is a really special thing. It is based in statistical theory. It's for continuous data, which means every possible decimal there could be. And if you look, and I may have mentioned this during the empirical, because we've already learned that area under a curve is probability, right? And when we're looking at this curve, if I wanted that area, that's really hard because see how it's a curve up at the top? It's not like it's a perfect trapezoid or rectangle or triangle or anything. So if we don't have those classic geometric shapes, we don't know how to calculate the area except for that mathematics called calculus. Don't worry, you don't have to have had calculus, but this chart is the results of calculus. So just saying that to do this very special normal distribution chart, we need to use the results of calculus. But again, we are dealing with unimodal and symmetric. Some of our shorthand notation is back. Remember, we used this when we were doing the empirical rule. This says approximately normal. And then what comes before the comma is the mean. What comes after the comma is the standard deviation. Now, we're going to have tons of different examples that we do next time in class. We're going to be looking at cork diameters. Maybe the mean is a centimeter. We're going to be looking at adult female heights. Maybe the mean is like 63 inches. We're going to be looking at like grades on a test. Maybe the mean is 75. So we have all these different real life examples, but I've only given you exactly one chart. So for this whole topic, and we're going to do more of this, of course, next time, you're going to always see me put up a flow chart like this because it's going to remind you that once we get to the word problems are always a two-step process. We've already talked about z-scores. That's the same z-score that we've already done, right? So, and the x is representing the actual like word problem, diameter of a cork, height of a female, whatever, the actual variable. I'm just going to write variable there. And the z, we know how to go from x to z. It's z equals x minus mu, all divided by sigma. We've already done that formula. I'm just kind of reviewing what we've done in the past. So every time when we have a word problem, we're going to have to turn our x into the standardized score, right? So that way, we can have one chart that does all of these different examples because I've standardized it down. So that's stuff we've already talked about. Today's video is all about just learning this part. If you have a z-score, how do you get the area or the probability? Maybe I should remind you that's what A stands for, area or probability. Okay? Or if I give you the area or the probability, how do you get the z-score? Then next time when we're in class, we'll work with the real life word problems. So going from z to a, or this whole thing can go backwards too, or a to z, you're using the z-chart. And that's what today's video is about. I'm checking my notes, make sure I don't forget to say anything. Okay. Since we probably just came off of probability, Jeannie and her chores and all that stuff, remember when we were doing basic probability, it was really important for you to understand what at least meant. Like at least 4 means 4 or more. But if it said greater than 4, it meant start at 5. Well, think back even before that. When we were doing the empirical, remember we said we don't really care about equality. So we are back to the unimodal and symmetrical curve. So I just want to remind you like that, just for example, x less than or equal to 4 is the same thing as x less than 4. So you don't have to worry so much about that. Or this could be a z, whatever. It doesn't matter because we are working with a continuous distribution. All right, let's talk about this curve briefly. So first of all, you do see there's 2 sides. And I hand wrote a big old Z at the top. If you look really close, depending on how good your eyes are, that little thing says Z star. That says Z star. So the Z-scores are the frame around the outside. Here are negative Z-scores. Here are positive Z-scores. That matches up to what we've already talked about when we were doing Z-scores, right? Remember, negative Z-scores are below the mean. Positive Z-scores are above the mean. Let me erase this in case I want to write something else. Okay. So Z-scores, this chart at least, and this is the chart that we're going to use. I go very old school here. It gives you the ones place and the 10th spot here, and it gives you the hundredths spot here. So we can get Z-scores to 2 decimal places. That's the limitation. So you're always going to see that I round my Z-scores to 2 decimal places, which might seem contradictory because I think I've been probably telling y'all to do 4 decimal places. That is why. But look at the 4 decimal numbers in the middle. These are the areas or the probability. And that is why, this is exactly why I've been making you do 4 decimal places up until this point for all the probabilities, relative frequencies, all of that stuff, right? Because I knew this chart was coming and I knew that it gave it to you in 4 decimal places. So all of the 4 decimal numbers here are areas. Remember X to Z to A, the area. All the 4 decimal numbers are the area. The 2 decimal numbers are the Z-scores. Okay. Sorry, y'all gotta wait a second. I gotta let a cat out of my room. Okay, I'm back. Well, yeah, I think that's all I wanted to say there. So let's practice some problems. Instead of like me pausing and giving y'all 30 seconds, right? You can always stop the video, go practice something, then turn me back on. Oh, sorry. I knew there was one more thing. It was really important. Look at the pictures up here. The black is the shading, okay? You see how it's shaded less than? This is a less than chart. It is going to give you the area or the probability less than the fence or the boundary, whatever you want to call it. And that's really important because if you remember, that's actually the definition of percentile. So a lot of people call this the standard percentile chart, but it gives you less than. So I can tell you right now, and we've done some of this even when we were doing relative frequency, if we need greater than, we're going to have to subtract from 1 because 1 represents the unit whole. It's decimal form for 100%, right? So it's really important to remember that this chart gives you less than. And I'm noticing my photo booth, it seems to be a little glitchy, but hopefully this video will play back fine. Okay, so we're going to practice right now. If I give you a Z, can you get the area? Okay, start off easy. What is the probability that Z is less than 1.97? Okay, so the reason why I called this one easy, because it is less than. So all I have to do is find 1.97 z-score on this chart, and when I get the answer, that's going to be my answer. So this is positive 1.97, so you want to be on the right-hand side. And coming down here, you want to find the 1.9s, because that's the ones place and the tenths place. But we need the hundredth spot of a 7. So take a look real quick. Find the 1.9 and the 0.07. You should see 0.9756. Pause me if you need more time. Okay, and that is the answer. And that makes sense, at least. Quick little picture. You'll see me draw pictures for every problem next time. We already knew that if you are the mean, your z-score is a 0. We know that you're about 2 standard deviations above the mean, so somewhere up here, right? And this one at that area, less than. Yeah, that looks like that's reasonable. I knew my final answer had to be bigger than 50%, right? So I think my answer looks reasonable. All right, let's do another one. What is the probability that z is greater than negative 0.04? So let me draw a quick picture first. All right, so this is a negative z-score. I mean, barely below 0, right? I don't know. I can't even draw it close enough probably because you wouldn't be able to see. In this problem though, remember, it says greater than. So it actually wants all of that. So if you look at your picture, at least you can see that your final answer has to be greater than 50%. Okay, so this is a negative z-score. So you're looking on the left-hand side, and please make sure you know it doesn't say negative 0.4, it says negative 0.04. So negative 0.0 is the very bottom row, because my 10th spot is a 0. I need the 100th spot of 4, so it looks like I'm finding 0.4840. I'm not done, but I want to make sure you found the 0.4840. Pause me if you didn't and go look again. But remember we said, wait, my final answer has to be greater than 50%. That's not greater than 50%. This chart just gave you this area, right? The less than. That's not what I wanted. So I have to go 1 minus 0.4840, which gives you 0.5160 as the final answer. So anytime you're doing a greater than problem, you have to subtract from 1. I'm going to erase, so pause me if you are not ready. I lost my third problem. Oh, here it is. All right, the third one we're going to do. What is the probability that z is greater than 5? Okay, now here's the problem. 5's not on the chart, but saying, oh, it's not on the chart, I can't do it, is not the correct answer. So the first thing I want you to make sure you understand is the smallest number I can look up is negative 3.89. And the biggest number I can look up is positive 3.89. All right, so anything past those is what we call off the chart. I'm going to show you 2 ways that you can figure out what to do when you're technically off the chart. All right, we are 5 standard deviations above the mean. And I've already realized it's off the chart. So I'm up here somewhere, right? And this problem has asked greater than. I'm exaggerating it because if I didn't draw that, you wouldn't even see what I've done. So that has to be a teeny amount. Saying that the answer is 100% is not going to make a bit of sense. There is no way that's 100%, okay? So when you're off the chart, basically your answer is going to be 0 or 100%. So that must be 0%, at least to 4 decimal places. That's what I call the intuitive approach. If you draw a picture and draw the greater than, you're like, oh, well, if my 2 choices are 0 or 100%, I'm pretty sure that's 0%. But a lot of students don't like that. So let me show you how you can use the chart. First of all, do you see how that's a positive 5? Okay. The biggest positive number I can look up is positive 3.89. Okay. Go look up that z-score. And if you do that properly, again, this is where you can pause me, you're going to see 1. But remember, that's representing 100%. That can't be the answer. Oh, wait, this problem asks greater than. Anytime I do a greater than problem, I have to subtract from 1, just like we did, I think, in the last question, right? So 0 or 0%. Okay, so that's how you can actually use the chart to help you solve the ones that look like technically they're off the chart. So he's kind of a weird one. Let's do another quick one like that, the weird ones. Okay, z less than negative 4.3. So again, you'll get the hang of, oh, well, this one's off the chart. Now, this one said, z-score of 0 is in the middle. This one said negative 4.3, and I know I'm off the chart, so I'm down here, right? And this problem wanted less than. So here's another example of, well, then it got to be 0%, intuitively. But if you don't like that, we're talking about negatives now. So the biggest, well, this is not a mathematically correct sentence, but the biggest negative number you can look up is negative 3.89, right? And when you look that up, again, you can pause me and go look it up. When you look that up, you're going to see 0 as the answer, as the area, as the probability. And that is correct because it is less than, the chart gave me less than, so that is your final answer. So that's how you deal with the ones that are off the chart. Okay, so briefly, I'm about to use a shortcut for the 5th example I show you, but I just want to briefly show you why the shortcut works. But then from here on out, we would use the shortcut, right? How do we do stuck in betweens, or at least that's what I call them, okay? Let's just go generically for a minute. Let's say it asked, what's the probability that your z is between two numbers a and b, okay? So this is just to convince you the shortcut I'm about to tell you works. Okay, let's say a z-score of a is up here. And if we look up whatever that z-score is, we would get all of that area, right? And a z-score of b, I'm just making up where to put them. Let's say that's down here. And if we look up that z-score, our z-chart's going to give us that. I don't have another color. But if we wanted the area stuck in between, look, black minus the red would give me what is stuck in between. So basically, you're going to look up both areas and subtract the areas. Would you like to know one of the most common mistakes? Students end up subtracting z-scores from each other. That is never a thing. You don't ever subtract z-scores from each other. Well, once we get to the word problems, I can tell you, you never subtract x's from each other. The only thing you're ever allowed to subtract from each other are the areas. So let's practice one of those. Number 5, I guess, for example. What is the probability that we get a z somewhere between negative 2.03 and a z-score of 1? Okay, so see what we mean by the stuck in between? So you've got two z-scores. So what you want to do is go look up the z-score of 1. Again, pause me, go do that yourself right now. Hopefully you got 0.8413. Now you're going to go look up the z-score of negative 2.03. Make sure you don't look up negative 2.3. It's negative 2.03. Pause me. hopefully you found the area of 0.0202. I'm sorry, 0.0212. Okay, now subtract those areas and you will get the final answer of 0.8201. That's how you do the stuck in betweens. You have to get the two areas. Now, for some reason, if you subtract the areas in the backwards way, the quantity is going to stay the same. You'd end up with a negative. Just don't write down the negative. We can never, ever, never have area of negative. Okay, so what we've done so far is, hey, if we have z's, how do we get the area? Now, we've got to reverse it. If I give you area, how do you get the z? Okay. So for right now, without the context of a word problem, because this one says, what values make up the smallest 2%? I'm going to just make the assumption that small is going to be on the left. We had talked about, I think it was on test 1, really keeping up with the variable. Like the word slow doesn't really tell you until you look at what the units of the problem were. We don't have a real life word problem, so this probably make a little more sense tomorrow, but we're just going to go with the assumption that small is on the left. So, see how they gave you the area. That's not a z-score. That's an area. So here is the area they're giving us, 2%. Take a second, pause me, and make sure you write that correctly in decimal form. Okay, which is 0.02. And you notice how I'm staying really organized. So many students, and I'm going to be telling you this next time in class, so many students are not organized like I am. I said that with a smile. They don't write the A equals 0.02. They just kind of write a 0.02 on their paper, and within 10 seconds they think that's a z-score, and then they go look up the z-score of 0.02, and then it's completely wrong. This is an area. Okay, all right, y'all aren't going to like this the first time, but I promise you'll get the hang of it. Remember all those 4 decimal numbers? I could turn that into a 4 decimal number just by putting 2 more zeros, because that's an area, a probability. You have to start searching. It's kind of like a needle in the haystack until you get the hang of it, okay? You have to start searching. Now, obviously, our z-score's got to be negative because it's on the left side of the middle, so you know you're on the left side. And there is patterns to this, right? The areas are much smaller up there and they get bigger down there. Try to find that number. Make sure you're not looking for 0.2. It's 0.0200. If you think you've gotten somewhere, then check each neighbor on either side to make sure you got the best one. So 0.02. Don't look at 0.002. That almost tricked me. 0.02. Like, real quick. I'm doing this organically. I'm not cheating. My finger landed on 0.0217. I'm getting close, but now I'm going to check each neighbor. 0.222. Oh no, that was worse. Okay, back to my 0.0217. Okay. I go to the right. 0.0212. Oh, that's better. Let me keep checking. Oh, 0.0207. Even better. 0.0202. Even better. And then I'm like 0.0197. That's not bad, but 0.0202 is the closest. So I just want to write the area you're supposed to be finding, okay? Now, once you find the 0.0202, put your finger there. I got to find it again. Oh, where did it go? Oh, it's right here. I kind of need 3 hands, and I don't have 3 hands. Send one hand out to the left and one hand up. And put that together to be this z-score. And if you need to rewatch the last 2 minutes, please do so. It's negative 2.05. It's not negative 2.5. It's not negative 2.005. Remember, the 0 up at the top is just a placeholder of the 10th spot. That number they actually show you is the 100th spot. So this is the answer to our first example. And again, this was your first time, so that may seem confusing. Just rewatch the last 3 minutes. And again, you will get the hang of it. It's just the first time's kind of scary. Okay. Pause me if you're going back. Otherwise, I'm going to move ahead. All right, the second problem. What values make up the largest 5%? Okay, so again, without the context of a real word problem, I'm going to assume that 5% is on the right. So we're talking this, and 5% is not 0.5, it's 0.05, okay? That is me purposefully sighing, because you're going to hear me say this 100 times in class. This piece of paper rules my life, okay? I have to talk to this piece of paper the way this piece of paper wants to be talked to. This piece of paper never wants to hear about who lives on the right side of the fence, because that's the greater than area. This piece of paper always wants to know who lives on the left side of the fence, the less than area. And I realize that must be 0.95. Now, where did I get that from? Anytime you have a greater than area, you have to subtract from 1. Oops. 1 minus 0.05 gives me the 0.95. That's where I got that 0.95 from. Because see this one fence? This one fence, there's only one fence, right? I can talk about 5% greater. I can talk about 95% less. It's the same fence. It's just that this piece of paper only wants to hear about the 95% less. This is an area, not a z-score. So again, let me rewrite this in black. If you want to go ahead and make that area 4 decimal places, so you remember, it's needle in the haystack time. You got to start looking all in here. This is one that's pretty special. When you get close, you're going to find that 2 numbers are just as good. You're going to find 0.9495 and 0.9505. So if you haven't gotten there, pause me, go find those. Both of those are equidistant from there. If you look at the z-score associated, this is 1.64. This is 1.65, okay? So what we want to do, since this is right in the middle, we want to find the z-score right in the middle. You could average those 2 numbers, but the quick and dirty way is to add a 5 to the smaller one. Like literally, I don't mean addition, I mean stick a 5 in the thousandth spot. 1.645 is the z-score. Now, if this is a testing situation, I'm going to tell you right now, I'll accept 1.64, I'll accept 1.65. But I just can't do that in front of you because you don't know it yet, but this is the second most famous number in statistics, and other charts that you're going to see the rest of the semester actually say 1.645. So I'm kind of trying to set you up for how I know you're going to see things over the next month. Okay, so if you have a greater than, you don't get to look for him. Because if you looked for 0.05, you'd end up with a negative z-score. This right here, look at this picture. This picture originally told me I should have had a positive z-score, which I did end up getting. All right, I think we have one more example. Kind of a stuck in between, but going backwards. Yeah, this is the one that's going to actually end up producing the most famous number in statistics. what values separate the middle 95% from the most extreme 5%? And it's really important, I think we've talked about this before, that in statistics, extreme just means away from the middle. So let's draw a picture first. Okay. So middle 95%, it's saying I need 95% between two fences. And see then the two tails here together, that and that, together would be 5%. So that means each tail is 5% divided by 2. 5% divided by 2 in decimal form. Hopefully this is sounding like a test question to you. You have to figure out what 5% divided by 2 in decimal form is. Take a second to do that. Pause me. And I hope everyone came up with 0.025. And I want to make sure you know that we have an area down here, 0.025, and we have an area up there, 0.025, because that's my 5%. And we want these z-scores. Now, we learned about symmetry when we were doing the empirical, that if I can come up with one of them, I know the other one has just changed the sign. And of course, this is going to be a negative z-score, that's going to be a positive. So really, I only have to do one of these. And it's so much easier to do this one, right? And why is it easier? Because this is a less than area. So I'm going to work with this right here. My area really is 0.025. Hey, this one's a nice one. If you go look this up, you will find this precisely. It's not like you got to check each neighbor. Now remember, you're scanning the body of the chart. So take a second to go do that. And you should see a z-score of negative 1.96. Okay. Now up here I still need to do him, but I'm going to cheat because I know symmetry. This would have to be positive 1.96. So stuck in between the 1.96s is 95% of the curve. The most, this number right here, these numbers plus or minus 1.96, most famous number in statistics. When we start confidence intervals, I don't know, in a few weeks, you're going to see that number come up so much. All right. So again, no context, no interpretations, no word problems yet, because remember in class next time, we have to get back to the real life problems about like how fast cars go or how much do dogs weigh or whatever. And then we'll get z-scores and then we'll get areas. Sometimes we go forwards, sometimes we go backwards. So remember today, the only thing we did was just this part of the sequence. So it's not all supposed to make sense, but you absolutely have to know how to use the z-chart. It's going to be part of every single problem. All right, that is all. Have a good day.